So what we're going to be doing is demonstrating the reaction rate of the enzyme catalase, which is found in this liver. The substrate that we're going to be using is the hydrogen peroxide. So the way that this works is we have this liver that is at room temperature.
Okay.
And so we're just going to take a little piece and we put it down in the test tube. And then I brought this. Actually, I'm going to use my stirring rod. So I'm going to take my stirring rod and just kind of push it down to the bottom.
Yeah.
And so this is just like a regular chunk of liver. I haven't done anything to it. So this is the control.
Yes.
So then the other thing that I am going to do is I'm going to measure about 4 milliliters of hydrogen peroxide. Maybe you only need 2. Yeah, I think I only need 2. So about 2 milliliters of hydrogen peroxide. And then we just take that. And so this is very much like the thing that we did yesterday, except that this is only like, what, 2% hydrogen peroxide? 3% hydrogen peroxide. So this is like significantly less potent than the stuff that we were using in the demonstration yesterday. So then you just add the peroxide to the liver, and then this is our rate of reaction. And so what we've got here is lots and lots of bubbles. Yep. And so the bubbles are very dense and they're coming up here, and it's actually also hot.
Can I feel it?
Yeah, of course.
Ooh.
Okay. And so that is the control liver. That's that rate of reaction. And just, because the cells of the liver, I mean, even though this came from an animal that's no longer alive, those enzymes are still in there, still breaking it down. So then what we do is, so then we're going to test reuse of the liver. So all I'm going to do is I'm going to take this over to the sink, and I'm just going to dump it. You put it in there, you push it down.
2 milliliters.
2 milliliters of the hydrogen peroxide. And then you add your peroxide, and the reaction's the same.
Yeah.
So the idea there is that no matter how many times these reactions happen, the enzymes don't just like go away. They don't get used up in the reaction. So the reuse experiment is just showing us that the enzymes continue to work. Okay. So then the other thing that we're going to do is, and this one is definitely the grossest, is we're going to take our liver and we're going to put it here in this mortar and pestle. I'm going to close my peroxide because, I said yesterday that if you leave it open, it turns into water. So I'm going to take my little grinder and I'm going to mash the liver up a little. And what I'm doing here is I'm like flattening it out. I'm increasing the surface area. And so what I'm actually doing is exposing more active sites, the places where the enzymes bind. I'm exposing more active sites to the air. So now what I'm going to do is I brought a little spatula. I'm going to scoop out this nice little tenderized piece of liver. I'm going to put it in a clean test tube. Try to get one with like a wide mouth. And then I'm going to push it down in there. And then we're going to do it again. So do you want to measure out my 2 mils of peroxide? What I'm going to do is, here's my ground up liver. Here's my hydrogen peroxide. Pour that in. And this one you can see that there's a lot more bubbles.
Yes.
They're also coming up a lot faster.
Very dense. Too.
Right, and to the point where this one is actually going to, a lot of times it comes out of the test tube. Okay, so we've got heat. And so what we've done here is by smashing up the liver, we've increased its surface area. We've exposed more of the enzyme active sites to the air. So the enzyme can break that hydrogen peroxide down even more and even faster. Yeah. And so let's see, we demoed regular, just room temperature liver, and then we reused that same piece of liver, and then we ground up a piece of liver. And so those were actually some pretty fast reactions. So then what